Okay, everyone, welcome. Let's go ahead and get started. Thanks for doing today's webinar, Access Any Container with Remoted Docker Jumpbox. Today, we have three panelists who are joining us, Jamie, Robert, and Brenda. The quick agenda, I'll do a quick introduction just for anyone who's new to Remoted. Then we'll go through a Docker desktop extension demo and a standalone Docker container demo. And then if we have questions that haven't been answered, we'll answer those at the end in a Q&A session. Okay. For anyone who's new to Remoted, we are a next-gen zero trust network access solution. We typically replace VPN solutions. Some of our benefits are we work when other VPN solutions don't, like devices without public IP addresses, so port forwarding is not an option, like you get with 5G mobile or Starlink networks. We work when there are multiple NAT layers. We also allow you to connect to as many private networks as you want at the same time. I've never met an admin, developer, or DevOps engineer who said they like setting up and maintaining their VPN. We actually remove all the hours of network configuration, so you don't have to worry about setting up route tables, subnet collisions, access control lists. We take all that off your plate, so it just becomes easy to connect to the devices and services you want, wherever they are. And while we offer better connectivity and less work and overhead in managing it, we also improve security. We eliminate external attack surface. We implement zero trust by allowing you to granularly assign permissions to specific services and not entire subnets. And we eliminate all the potential manual configuration errors that can happen with a typical VPN solution. If you need more information, go to our website, www.remote.it. And if you want to talk to someone live, there's a link at the very bottom of the web page to schedule a call with someone to discuss your specific use cases. With that, I'm going to turn it over to the first demo and turn it over to Jamie.
Okay, thank you, Davin. Let me share my screen. There we go. Hopefully you can see there. Okay, so I'm just going to go over our Docker desktop extension, which is actually a Docker Jumpbox, which means that once you install this in your Docker container network, you have access to all the services within that Docker container network. There's an added security layer and convenience because you don't have to actually expose any of the services that are running within the Docker container network outside of the network, since the Jumpbox is inside the network. And what it does is it actually, once it's in there, it uses and connects to the Docker APIs and the Docker events to kind of synchronize all the activity in Docker within Remoted, so that it will update and easily see if your services are online or offline, or if they've been created or taken down, and just makes it really convenient and easy to connect to and control access to your Docker network. So in the Docker desktop, you can see here, we've got the Remoted extension installed, and you can find that in the marketplace. So the first thing you need to do is register the container so that we've done this. So then what we've got to do now is register the containers with your Remoted account. And so you can just get registration code. Have that window active instead of the one off screen, and it will open that up. It'll generate the registration code and then return you here with it. So there's your code. And if you want to get a registration code manually, you can go up here through the add device and find that stuff, or you can also use a restore code if your device was deleted and you want to restore it. So we'll just register that. And we should see when it registers in here, this should update. Yep, there it goes. And you'll see it's already used the API to find what's running in my containers, in my Docker network, all the containers, and you can see them coming online here. So you can just as proof, these are all the containers that are running, and you can see here they've got the container and the actual service. So it's found the services that are running on these different containers. So these are other Docker extensions that are a single container that just does a direct connection. So these are just some kind of sample ones. Got a little echo server and a little visitor log server. So now I'll show you. So this will do the same thing as going in there and jumps to the device. So once we go to the device, now that it's in Remote It, we have control over who sees it and who can connect. So actually the first thing we will do, which is kind of fun, is this visitor log thing it's just a simple web server that is kind of a demonstration of how we actually do have access to this service. And we can make a public URL for that. You can see there's a little warning because it is actually exposing this to the public. And if I have this public URL here now, I can actually share that with everyone. I don't know if we can, how that works in this webinar, but I'll put it in the chat. And then if we launch that or connect to it, you'll see it's just a little visitor log, and you can see, so it tracks the different addresses of people that have connected to it, just the refer addresses. So that's kind of cool. That's a very easy way if you need to share something that's, you know, directly some little web thing outside to the world. Let's see. So then, like I was saying, so if we want to control access to this thing, so the way that things are set up in Remote It is that you can have networks. So we've got a few networks here set up in our Playground account, and they're tagged with different things. So this one's tagged with tech support. And then in our organization, here's our organization members. You'll see some of them here are tech support members. And in the roles, if we look at our tech support role, you can see it has specific access to 2 networks with the tech support tag, and these users can view and connect. So now if I go back to that device and I say, okay, well, this is something that I want tech support to have access to, I just do that. And now you'll see this is part of the tech support network. If you go here, it's in the tech support. Now these people basically have it. And that's how you can control who has access to what's in a real simple way. So yeah, so that's visitor log, showing the networks and the tags and the roles. So the next thing I wanted to show is how simply and how nice this is to update. So if I do something like I go into my containers and I install an Nginx system, I already have this in here. So if I run that, we should see in here, what is this? Competent Hopper. So you can see that's also been discovered. And then as that starts up, these things should come online. And then now I can simply launch that. Oops, wrong one. Competent Hopper, there we go. Launch that. And we should see an Nginx server. Whatever, I don't know. Looks like maybe the Nginx didn't install correctly. Well, that's not on our side, but oops, sorry about that. So yeah, it's exited for some reason. So you can see that, I'm not sure why that happened, but maybe I installed the wrong Nginx container. But if I do delete it, because it was bad, it should disappear from here too. Let's see. Yep, there it goes. So that's the installing and removing of Nginx. And then the real powerful thing is because, you know, there are limited uses for the Docker desktop, you know, on your system in terms of real use and real production use. What you'd want to do is have this same extension out in a production environment or anywhere else in the world that you have Docker containers. So if you want to do that, you have this registration code here. It's got the same registration ID. So if I copy that and I actually just install that via the command line, you'll see a new container will be generated, a Docker remote Docker jump box. And there it is. Oh, I forgot to rename it. But yeah, so there's another one directly just installed through the command line. You can see how quick and easy that is too. And now you can see that one's also starting up and all the things are coming online. And we can just test it with this Echo server and see what happens. And there it is. So that's echoing. So yeah, so that's the new thing in installing to the command line. And then you can see that you actually don't need the Docker desktop at all when interacting with this to kind of monitor your servers and things. So like if I just go here and showing in desktop that I can do a, just run Docker commands directly. So if I do like a Docker stop echo server, whoops. We should see our echo server stop. What's happening? Exited. It's exiting, but it's crashing, but not shutting down. That's why it's not. Sorry. Oh, there it goes. Okay. So it took a little bit longer because it crashed instead of shut down cleanly. But, and then if I do a Docker echo server, we should see that disappear also. So you don't actually need to do the using the desktop at all. It'll take a little bit, but I wonder if it's there. It goes. So anyway, that's kind of what I wanted to show. And from here, I think Robo is going to talk about how it goes, how you can use it in an actual production environment. So I think I'll hand it off to him now. Thank you.
Thanks, Jamie. Okay, so as Jamie just alluded to here, what I'm going to do is I'm going to take this Docker run command here, and I'm going to convert that to a ECS task in AWS. And we're going to run this on our ECS cluster over multiple instances and show how that same daemon, Docker daemon API works and gathers information from our ECS cluster. Right now, we have an ECS cluster out there in AWS. It has 2 container instances, and it's running a couple services. It's actually running 3 tasks, but it's running a remote Docker extension, which is that same thing that Jamie showed, just running as a task. It's running as a daemon, which means that every time we launch a new instance in our cluster, if our cluster expands up or expands down, it's always going to run one of our remote Docker extensions on each one of those instances, and it's going to pick up each of the Docker containers running on those instances. So what we have now is we have the 2 instances. We have the Playground ECS AMD 6400 and 01. If you notice down here in our security for this, we have no inbound ports open, none. So what we're going to show you is what Davin talked about, this zero trust. And basically there's no open ports. So you can't get to this any other way unless you had a VPN into your private subnet or something like that. There's no way to reach this. And we're going to show you how we do it from our desktop. The same with the second one here, the open rules. So just to confirm here that, it's zero trust. All right, this is the remote Docker extension task. And what I've done is I've taken this, you'll see here, there's a registration code, there's a volume to the Docker socket, there's a name. And what I've done is move those in here. So we have the device name is the way I'm doing it here. Arthur, instead of using the dash name, we also probably have a name up here. We have the name, the registration code. So these are our environment variables. So we have our registration code, and then we have our mount points, the volume for the Docker socket, just as you would have over here. So I've just converted this into this task. I've added this extra host.docker.internal. On Linux, you don't, on your Mac or Windows, you get this by default, but on Linux, you do not. So in order to match that, I've kind of added it in here as an extra host. And we know the IP address, internal networking IP address of this instance in this Docker network. So it'll map to that gateway. All right, so now we have these tasks running. If I look at my remote desktop here, I see I have the 2 ECS Playground, and I see one of these has 2 services and one of these has 4 services. So we're going to look at the first one here. The 2 services here, these are manually added services. So this is to show that you can manually add services as well as the Docker container services that get added. So this actually gets to the metadata service on the host instance. So it goes from the container down to the host instance. And this actually does an SSH from our remoted Docker container into the Docker host. So we can actually get into there as well. If we look at the next one here with the 4 services, we see we have our Echo server task running. This has 2 ports, port 80 and port 443. This was automatically picked up by our remoted containers. So what I'm going to do now is I'm going to take this Echo server task, and you see that we're going to update the service, and it says that we're running 1 task. So let's run 3. That's actually more tasks than we have instances. So it's going to double up a couple of these tasks. This is just how you would have in production. Sometimes you have, multiple of the same microservice running on the Docker instance. And I'm going to update that. And you're going to see that it's going to start launching these tasks. So if we look at the deployments here, you see that we have a red here with 33%. It looks like it's getting ready to come up, has reached a steady state, and it's going to start launching a couple of these tasks. As it's launching these tasks, we should see in our device list, we should start seeing more. See, we had 4 before, look, 4. Now it's adding more over here. We had 2 there, so it's added 2 of those. So it looks like that it's updated already. And we can go in here now to our second one, and you can see we have the Echo server, and it's kind of doubled up. It has 80 and 443, 80 and 443. But what you have is you see your container IDs underneath here. These are 2 different containers. So these are multiple containers running on the same Docker instance in your ECS cluster, and I can get to both of them. Okay, so if I just click on one of these on port 80 and I say start, it's going to take that, it's going to connect, and as soon as it connects, there we go, we're going to launch it. And there we go. It's an Echo server. It tells me the host name is the instance name, really, in the ECS cluster. It gives me some information. And as you notice here, it comes from an X forwarded for 127.0.0.1. That's coming from my local machine. It thinks our port is on the local machine, and this is how we get to the instance. Is there's a remoted agent running on my local machine. There's the remoted agent running in that container out in the instance, and it's making a connection, and it thinks it's just that port is local to me. And how do we know that? We look right here. This is our host name right here. So if we do a dig on that, what you'll see is it actually comes back as my local host. So all we're doing is creating a name for your local host to make it easier with, a domain. And this helps with our SSL or TLS and all that. And then we give it a local port. So that port is actually local. Okay, now the other thing we can do is we have these other services that I did. I did the SSH to the Docker host. So let's go ahead and start that one. And I'm going to actually start it on both of them. And I'm just going to start it this way. You can also start it by this little button on the side there. Okay, and now they're both connected. So now what I can do is, since I have SSH access, I can actually go here and I can use that SSH to the ECS Playground host at Remote at 33053. And let's see which one we're at, 33052. So this one would be 33053. And you can see that we can actually run remote Docker hosts and show what's running on those instances from my local machine. So I'm actually running a Docker command, a PS, to list it. So this is not my local one. If I do a Docker PS on my local one, you see there's a difference. I'm actually telling it the host is a connection out to that ECS cluster. I am running remotely commands that you would normally SSH into it and run this command on the instance. I'm running it from my local machine. And we can do it for both of those. So as we do that, you see that there's a different list on this instance. So I have one for each instance here. We've connected to through that, there's no open ports, through there to SSH and port 80, and we've raised up these number of Echo servers. If we go back here and we update the service again, and we set that back down to 2, and we say update, it's very dynamic. As Jamie showed, what should happen now is at some point when we go back to our devices, I like to look over here. This should go back down and kind of match each other now, hopefully, or it might get rid of the two over here, the echo server, and leave both of them on here. We don't know. And this is the whole reason behind having this dynamic connection to the host. You never know where these containers are going to go on your ECS cluster. So right now I'm waiting for it to deploy. So it says it updated. We have 67%, three running, 2 desired. So we're still waiting for that to go down here. Let's refresh that. Let's see. And now we're running 2 and 2 desired. And you can see 2 of them went offline here. Those 2 ports. It's 1 container, same container, but 2 ports is now offline. And at some point, those will get removed as well. Oh, no, they won't get removed because in Docker, if you run, for example, let's see if it's this one. Nope. Let's go back over here and run -A. So what they have is, see this one exited 36 seconds ago. What happens is when it actually stops that container, it doesn't automatically kill it. It just stops it. And so these are going to stay in the stop state. So you can see that this container, there used to be a container running there, but it was removed from the cluster, but it's still stopped and on that instance. And I think they do this at AWS in order to roll back if something goes wrong. They haven't killed the whole instance. They could just restart that container and do a rollback on deploy. So anyway, that's exactly, so it's doing exactly what it is. This is stopped. It's still there, but it's offline. So we know it's offline and it's not usable. You can't connect to it anymore, but we know it was there at one point. And so that there basically shows exactly how you would run this in a production environment. And it looks, works really great for connecting to your and debugging your containers on your instances in ECS or any other Docker environment for that matter. And that's pretty much it for me. So I think at this point, I will turn it back over to Davin, sorry, Davin.
Okay, so looks like all the questions that came in during this session were covered by the presentation materials. But if there's any other questions, just put it into QA now, and we'll go ahead and make sure we answer those. While we're waiting for any last minute questions, again, all this information is available on our website, and specifically the Docker downloads are available on Docker Hub. But again, the links are on our website. So if you follow the website on the workflow, you'll eventually get to it, or you can just go and Google search it on Docker. Okay, so it doesn't look like there's any other questions coming in. We'll wait another minute to see if anybody has any last minute questions on how they might use this or why, our solution works in certain cases, anything like that, just let us know. Brenda, did we miss anything that you wanted to add?
At this point, no, but you can find all the links of the things that were demonstrated by Jamie and Robo on both GitHub and also on our website. So we encourage you to try this out. So far, the feedback from our users is that this is much easier to manage access to your Docker containers.
Okay, so it doesn't look like there's any other questions that have come in. So I guess we'll close the session. But again, for any follow-ups, go to our website and ping us if you need help on any of our, contact us methods or, on whatever sites and social contacts you may use. But thanks everyone for joining and have a great day.
Thank you. Bye.